Here we are with the first video of Unit 7 called Interior and Exterior Angles of Polygons. Unit 7 is all about going above and beyond just three-sided figures. Now we're going to get into polygons, which polygons means any figure, three sides or more. For this section 7.1, we will focus more on all the polygons, but after this, we're kind of going to narrow it down to four-sided figures. So our first main topic is finding the sum of the interior angles of an object. Polygon, three sides or bigger. So how this works is, if I give you a picture, and you can see our quadrilateral, four sides, pentagon, 5, hexagon, 6. If you want to start drawing diagonals and making little triangles. So here's my first three objects drawn for you and the idea of what it means to draw a diagonal. So our quadrilateral or four-sided shape, we'll start with the most basic, our square. I have number of sides, 4, number of triangles. So I'm only going to be able to draw one diagonal, and you can't draw any diagonals that cross. So this doesn't work. The diagonals can't intersect. So drawing non-intersecting diagonals like the pictures you see here. So if I was you, the easiest way would just be to pick any corner. So I picked this leftmost corner on these two, and I just started drawing diagonals until I couldn't draw them anymore. So I hit that one. So if I can't draw this because that's not a diagonal, that's a side. A diagonal goes through the shape. So how many sides? Back to our quadrilateral, we got number of sides. Number of triangles is 2. Sum of interior angles. Well, how many triangles do we have? 2. We all know the interior sum of a triangle is 180. So now it's just 2 times 180. We take our number of triangles and multiply it by 180. And the interior sum of any four-sided shape is 360. So let's look at pentagon. Pentagon, we have a 5-sided shape. I picked a corner. I drew as many diagonals as I could without drawing a side or intersecting any diagonal. So I couldn't draw this diagonal because that would intersect. So how many triangles would I have here? I would have 3. And then that's our multiplier, 3 times 180. There's your interior sum of every 5-sided shape. Hexagon is 6 sides. So draw my diagonals of this one corner. 1, 2, 3, 4. There's our multiplier, 4 times 180, 720. So heptagon, not too familiar with a heptagon. We don't really use a heptagon too often. You probably, maybe not even ever seen this word before. That's 7 sides. And yes, hope you're catching a pattern. I'll continue it. It does have 5 triangles inside it. And I would take 5 times 180, and I'd get 900. So this is really cool if I give you a picture and or the sides are fairly small. But then we run into problems if our polygons have more sides than like 1-digit numbers. What happens when we get into polygons with 22 sides or 24 sides? We have created, there is a formula we can create through this pattern. Well, how the pattern was discovered was they noticed after the triangle and quadrilateral that it was an increase of 180 interior sum every time. And notice on a quadrilateral, we had 2 triangles, and this number is very consistent. 2, 3, 4, 5. For the 8, the octagon, the next one would be 6. So our formula says take the number of sides and subtract it by 2, and n means sides. So n is sides. Number represents the number of sides. So look, heptagon, 7 sides. We subtracted by 2. There's your 5. And what did we multiply it by? 180. And there is our formula for finding the interior sum of any polygon from 4 sides to 104 sides and beyond. So we really need to know what it means for when I call something a regular polygon. What does it mean to be regular? A regular polygon is one of those really nice, what we want our objects really to look like. What we could kind of say, it's perfect. What I mean by that is all sides are equal, all sides are equal, and all angles are equal. So if you look at these are nice. If you kind of ignore the diagonals, they're perfect. All sides are equal, all angles are equal. So what this formula here I'm going to give you is, if we have a regular polygon and all sides are equal and all angles are equal, to find the measure of an or one interior angle, we would just take this formula and then divide it by the number of sides you have. And it only works if it's regular, since we can divide it evenly into all equal pieces because all the angles are equal. So here's our two formulas that we're going to work with on these. Okay? Find the sum of an interior angle of a 15-agon. There's your sum formula. So we would just say 180 times our number of sides minus 2. So it's just 13 times 180. Find the sum of an interior angle of the interior angles of a 21-agon. It is the exact same thing as this, but now you'll use 21 minus 2 times 180. So same thing over here. Number 3, what is the measure of each? So we can use a angle, an angle, each angle, or one angle. These are the 4 key words that want us to work with that formula. What is the measure of each interior angle, or I can say one, or a interior angle, or an interior angle of a regular pentagon? And next, notice it says regular. We need it to say regular. So we would grab this formula and we would insert pentagon has 5 sides. So we would insert a 5 here. And I already did that. 5 minus 2 times 180 up here is 540. So I already know that. But then we would divide it by 5. So 540 divided by 5, the answer to this would be 108. What's the measure of each? There's our keyword, and regular. That's the 2 things we need to know. And now I can just use, I can just use this formula. And now I'm putting 18 in. So I'm going to take 18 minus 2, times it by 180, and then divide it by 18. And then the answer here would be 160. All right, to the back page. Exterior angle sum. Okay, exterior angle is when we get to do half circles and next to one of those interior angles and do half circles. So when we see lines extended past and we get to do half circles, the exterior angles are all these guys, these angles on the half circles. So On a triangle, how would you find the sum of these? So I would say 180 minus 40, 180 minus 79 here, get this angle. 180 minus 61 to get this angle. And the sum of these, if you do the math, you'll get 360. Okay, so let's see. Triangle has interior sum of 180 and an exterior sum of 360. And every triangle has an exterior sum of 360. So how would you go about finding the exterior sum of a quadrilateral? So you would do a half circle on every corner. 124, subtract that from 180 to get that. 180 subtract 71. 180 subtract 89 to get this one. And 180 to subtract 76 to get this one. And the exterior sum of these, when you add these 4 exterior angles up on a quadrilateral, is going to be again a 360. And I'm going to go ahead and tell you that the conclusion is every polygon has an exterior sum of 360. And it does not matter how many sides it has. You can challenge this if you want. Go ahead and say 180 minus 121, get that one. 180 minus 98, get that one. 180 minus this, 180 minus 130, 180 minus 87, get all 5 of these, and I guarantee you it adds up to 360. And it works on every one of these. All right, sorry, I had to pause it, had someone at my door. Okay, so in a hexagon, same thing. Do all these half circles, they have to 360. Okay, what's the measure of each exterior angle of a regular polygon? So here's the formula. So I'm about to give you a formula here for what's the measure of each exterior formula. What you would do is take hexagon is 6. What's the measure of each exterior angle of a regular hexagon? You take 360, because it's going to be exterior. Anytime you see exterior, you think 360. And divide it by 6. And that would be the measure of each exterior angle of a regular polygon. What's the measure of each exterior angle of a regular polygon? 24gon, sorry. Here you would say 360 divided by 24. If the exterior angle of a regular polygon measures 12, how many sides does the polygon have? If we're solving for sides, n is sides. So what we'll do here is, you see this right here? We're going to take that formula, but we do not know the number of sides. So we're actually going to say 360 divided by, I don't know. But I do know it equals 12. So all you have to do is basically, the little quick way to do this is to replace the n and the 12 and take 360 and now divide that by 12 and you get 30. So I really, in my calculator, I said 360 divided by 12 and I get the number of sides is 30. I'll do it again. If the exterior angle of a regular polygon measures 40, how many sides does the polygon have? 360 divided by the number of sides equals 40 degrees. I'm just going to substitute these out. So now I'm going to say 360 divided by 40 is n. So 360 divided by 40 is going to be 9. This thing has this thing has 9 sides. So here is what is going, look at all this. This is going to be huge help for your assignments and quizzes. If it's an open note quiz, and I'm confident that it's going to be, these are the formulas you need to know. If it's not an open note quiz, we're going to do these enough times to make sure you memorize them. The sum of interior angles of any polygon can be found by that formula we talked about, 180 times n minus 2. Interior angle of a regular polygon is going to be that divided by n. We did that on the first page. So there's the two formulas we did on the first page. Interior sum, interior angle. Remember, that's when I said an angle, a angle, each angle, or one angle of a regular. Very important that it says regular. Sum of exterior angles of a polygon. There's no formula for that. It's always 360. Exterior angle of a regular polygon, each exterior angle, this is that one we just did right here, is that 360 divided by n. Number of sides of a regular polygon. Number of sides for a regular polygon, I think I have that over here. It's the 360 divided by exterior, this guy right here. 360 divided by exterior angle. 360 divided by EXT, that's exterior angle. That's an angle symbol. 360 divided by exterior angle. All right. So there is your notes on that. So here's what I want to do is I want you to try these questions, the practice questions, next. And that is the next page in this packet. I want you to try these practice questions and let's see how far we can get.